Hello, my name is Milan, and this is my first video of my tutorial series on STM32 register level programming. Please bear in mind, this is my first tutorial video, so please be tolerant to some fails, and I will appreciate your feedback and suggestions. Why am I doing this series? There are two main reasons why I do this. The first one is, during my programming experience, I sort of started to forget stuff which I've done like 6 months ago, etc. And I want to use YouTube platform as a way where to sort of store my memories and my mindset used in the programming. The other reason is that the videos are quite widespread all around the internet. It's very hard to find some sort of accumulated source of knowledge on register level programming. And second reason is that this topic is actually not very well covered on YouTube. I don't really know why, because in a logical sense, every embedded system requires some sort of register level programming. And I strongly doubt that everybody uses Arduino or STML, hardware abstraction layer, to do a programming on some sort of product which is going to be released on the market. My experience with programming started logically with Arduino, and I used Arduino wiring library or language. Then I moved on Atmel 8090 CAN 128 microcontroller. This microcontroller was quite a large leap for me because this was my first ever experience with register level programming. Overall, Atmel platform, 8-bit MCU platform, is quite solid, and I definitely do not want to talk bad about it. The reason I moved on STM32 is I just needed to get more out of a microcontroller, and Atmel has some limits. I moved from Atmel on STM32, and my first ever experience was with Nucleo 144 and STM32F7. This is very powerful MCU series, and I programmed them using CubeMX and hardware abstraction layers made by ST company. The point of this YouTube series is to explain how some basic functions of the STM32 MCU. I want to teach you where to find things in a datasheet or reference manual. I think it is far more important to know where to get the information than to store the informations in your head. My head is not a hard disk, that's why I do this series. So without further ado, let's move into creating stuff. The first topic is GPIOs. I'm going to blink a diode. So let's go. I will use the STM32 Cube IDE. You can, for example, use even like Microvision, things like that. I used Microvision, but Microvision, the free license, it has limitation. The limitation is that you can write programs up to 32 kilobytes, and that's certainly not enough. Certainly not for STM32 MCUs. So this is, for example, if you will freshly install this application, it is free, completely free on ST websites. You will get like a startup window. I don't have it because I already did some stuff today. So I will just start with new project. I know you don't see it because I have it windowed, but you will just press File on laptop and go to New STM32 project. And here we go. So at first we have to select our RCU or board. I will be using the Nucleo 64 board with STM32 F303RE MCU. Good stuff. I bought it on Farnell, if you're interested. So, board selector, Nucleo 64, it's over here. And it's F303, so let's go F3. And here we go. There are actually some basic information about it. This is basically a headline from datasheet. You can actually download documentations. Here you can download the documentations. Actually, these are only for Nucleo, so you have to... I will talk about it later. Let's name it. I will just name it GPIO tutorial. I have default location, you can put it wherever you want. C, executable, STM32 cube. I will use the STM32 cube IDE or MX just to set up the clock. I don't want to delay myself with showing you how to set up the clock. I think the first video should be about blinking and LED. And maybe you will have faster loading if you have some more powerful machine. And here we go, it's alive. So, clear pinouts. The reason why I do it, just I want as clear empty MCU as it's possible. Clock configuration. I will use internal oscillator with 48 megahertz. Basically, how the clock works. You have two sources. You have internal and external source. Now I want to use internal. There is an internal 8 megahertz oscillator. And then there is PPL multiplicator. And as you can see, it can multiply up to 16 times. And it will multiply 6. It's set it up automatically. I can, for example, write, let's say 32 4 times. 40 5 times. I want to use 48. So let's go with 48 megahertz. And this is actually everything we want to set. Everything is empty. So let's generate code. Yes. Okay, so this is our main.c file. As you can see, we have some sort of predefined structure, some sort of commands. The important thing to know is, if you would ever write a code inside it, you must write code inside these commands, where is like begin and end. If you would ever write a code over here, and you would then make some adjustments inside CubeMX window, generated the code, and suddenly you would go back to main and realized then that all the things you wrote are gone. So just bear it in mind. But it is also good because it gives you some sort of overview of the structure of the code, what it should do. Let's save. Let's begin with the very simple thing. We want to blink an LED, which means there has to be some sort of event which turns the diode on, some delay, other event which turns the diode off, and delay. So let's start with the delay function. At first, I will make some sort of define. The delay, let's keep it 1000. Private variable will be say like this. 0 for now. So this integer will, in the moment of calling of delay, receive this value from this macro. Private function prototypes at first. Let's make delay this. Yeah, that's probably good. Timing delay equals delay. And now file timing delay is not equal 0, remain in this empty loop. So basically now what this function does, we had a volatile unsigned integer, which is for now equals 0, but it will receive an unsigned integer delay, which will have value 1000. So the timing delay will be equal 1000. And then there is a empty while statement that timing delay, if it's not equal 0, remain idle, let's say. Well, but how do we decrement the timing delay value? Well, for this, I will use the SysTick timer. The SysTick timer is usually used in real-time operating systems, but because right now I will not use it, so I can use it just like a regular timer. The SysTick timer will throw interrupts at times defined by me. I will set it for 1 microsecond, just like Arduino has it. Do it like this. SysTick config, and I will define clock create, say so wrong MCU clock, and let's divide it by 1000. So the thing I have done is that I have set up the SysTick timer to throw up an interrupt every, I have here 48 million because I have frequency 48 megahertz divided by 1000. So every 48,000 cycles, it will throw up an interrupt. And as we know, 48 megahertz divided by 48 kilohertz leaves us at 1000 kilohertz. And the period is 1 microsecond. So every 1 microsecond, the SysTick timer, which is directly connected to the internal oscillator, internal clock, that's as accurate as it can be. So every 1 microsecond, it will throw up an interrupt. The thing is, for now, I will leave it like that it will throw the interrupt for the entire time. Even though we are not using the delay, the SysTick timer will still interrupt, but it's okay. Now we need to use SysTick handler, and it's actually over here are the interrupts. STM32 F3XX IT.C. See, like hard fault handler, post fault, usage fault, but we want SysTick handler. I will actually copy it because it cannot be defined twice. I cannot write one SysTick timer over here in main and other over here. But because I want it in one file, I can just move it like this over here. And basically the only thing it does is that every microsecond it will decrement the timing delay. So it will move to 1000, 1000, idle, and with every interrupt it will get decremented by 1, and in 1 second it will be equal 0, and the program will get out of the delay function. So now we have set up our delay function. So the thing we have to do next is start setting up the GPIOs. For this, we have to move into the documentation. This is our reference manual. This is the datasheet. Both can be downloaded from the ST websites. You will just find the type of the MCU over here, like it's called STM32. This is the series, so you will just type it. You will find documentation and you will download it. The thing is that the datasheet has some sort of, I think it's named product specification or something like that. It's hidden. It's not really a datasheet. For now, I will switch to reference manual. And the very first thing we have to do before setting up the GPIOs itself, we have to enable the peripheral clock. For this, we will go to the chapter with RCC, reset and clock control. And I will skip a little. You can read it by your own. I will go right to the registers. And I know already where it is. You will find register peripheral clock enable register. And depends what pin you want to use. I have decided that I will switch on and off 2 diodes at once. And it will be pin 9 and 8. So it will be PC9 and PC8. And as we can see over here, input output, PC. It's 19th bit of the register. And if you will go down, here we can see input output port C clock enable set and cleared by software. That's us. If there is written by like it does something by software, you have to write it. If it's by hardware, the MCU does it by itself. And we have to write 1 to enable it. So let's go. I will write it directly to our main. We can make it a function later. So it is a pointer to a struct RCC, and it was this one. And we are setting a bit to 1. So like this. Oh, sorry. And now RCC. And we have to find our GPIO. Here we can see GPIO enable. So the thing I'm doing is that I'm making this register. I'm adding 1 on position 19 because there is a left shift 19 to this register. Basically, it could be like this is equal this and this. Basically, but I make it easier. It's shorter if I write it this way. So this is when you are setting or adding 1 to a register. So now we enabled our clock. Now we can finally work with our GPIOs. So let's go again to the reference manual. We can close this chapter. And let's go to GPIO over here. I will go straight up to registers. Okay, and let's start from top. So here are the registers. And we start right with the motor. The motor sets the mode of the register. You can see if we put, for example, I know I am using pin 9 and 8. So if I will put 0, 0, it's input mode and it's default, reset state. 0, 1, output mode. 1, 0, alternate function mode, timer or something like that. If I want ADC, 1, 1. 1, 0 is, for example, USART or I2C communication. So from this we can see that we want 0, 1 over here and here. 0, 1, 0, 1. This will be zeros. This will be zeros. 0, 0, 1, 0, 1. So let's do it. GPIOC macro. Struct, sorry. Motor. At first we have to null the register. Or we can just null the pin 9 and pin 8 position. We do it like this. I know it's 9. And 8. Again, the thing I'm doing is that this is value 3 on position 16 and on position 18. We can see position 16 and it's 3. In binary, 3 is 1, 1. This is 1 and this is 2. If we add it together, it's 3. So on position 16, it's 1, 1. And on position 18, it's 1, 1. But this is a not statement. So it means that there is not 1. There will be 0. And because it is AND, this is AND, and this is 0. So if we had 1 here, and here is 0, it will null itself. I will show it to you more directly. Basically what I'm doing is, sorry, I will delete this. This register, which is an integer, for example, over here is 1, 1, 1, 1. This register is entirely 1, but I will make sure that on these positions will be zeros. Because there is a NOT, which makes these two zeros, and AND, basically this is 1, this is zeros, it will equal 0. Simple. And again, let's make it shorter. Boom. So this is our model register. Let's move next on O-typer. Basically here we can leave it on the reset state. Open drain you will use, for example, in I2C communication. We are not using it. Push pull reset state, we are okay with it. But just for assurance, we can still write it to 0, right? Typer. 9. And I completely forgot to set up the motor on output mode. So what happened? You can see this macro expansion moves value 1 on position 16 and this on position 18. And we can see from the datasheet, the reference manual, sorry, 16, 18, 01 output mode. Perfect. Here is our O-typer. Speed register. Basically, we can keep it low speed as it is. Pull up, pull down register. Actually, over here it's worth it to write 00 because if you have accidentally set up internal pull up or internal pull down, it can make problems if you really forget what you've done. I will write even the O-speeder so you can have seen it. Again, value 3, 3, 3, 3, and we are nulling these positions. So this is basically all for the basic setup. So with the GPIO set, let's move to the final part where we will set the individual ports on and off. For this, we will find port bit set reset register. And over here we can see there are 2 rows. The bottom 16 positions are reserved for setting and the upper 16 positions are set for resetting. You can see it over here. Port X set bit Y. These bits are write only. Yeah, if you will try to read, you will get value 0. So let's set it. Let's go to the while loop. Over here. GPIO C. ESRR. And we are setting, so 1. Like this. And we are setting position 9, 8 and 9. Right. So now we are setting. Now let's move delay. And our delay is Actually, LED delay. Let's put it in. Now we want to reset these bits. IOC. For this, we can either use this bit set reset register or simply BRR, which is bit reset register. Actually, I can show it over here. It is defined. It's not. Yes, over here is BRR. Basically, what BRR is that the BR bit reset is not the upper values from, let's say, from 16 to 31, but it's from 0 to 50. I will use BRR. And to reset, we have to again write 1 to those bits. It will automatically, the hardware will automatically set it back to 0. Okay, you can see 001, 002, 001, 002. And again delay. We should be okay. Let's build. Perfect. 0 errors, 0 warnings. Okay, so let's upload the code. I use run. Yes, yes. I usually keep everything default. We just apply. Okay. Okay, the LED is blinking. Now I will just record it for you.